Hey guys, what's up? As requested, this video is going to be about circles and straight line graphs. And let's begin with a quick recap of what we know about straight lines. The equation of a straight line is going to tell you the gradient and the y-intercept of the line. So m is the gradient and c is the y-intercept. We also know that the gradient is equal to rise over run, or the change in y over the change in x. So here, if we go across 2 squares, then we go up by 4 squares, and so rise over run is equal to 4 over 2, and so the gradient m is equal to 2. If we look down here, we see that the y-intercept is minus 2, and so our equation for the line is y equals 2x minus 2. Alternatively, you may have to find the equation of a line given 2 of its points. So let's call this point here 2, 2, and let's call this point here 6, 10. So again, the gradient is equal to rise over run, or the change in y over the change in x, and the change in y is 10 minus 2. The change in x is 6 minus 2. And so our gradient is 8 over 4, which is equal to 2. At this point, we can use the equation y minus y1 equals m times x minus x1, where x1 and y1 are any point on the line. So we could use the point 2, 2, or we could use the point 6, 10. Let's use 2, 2, so y minus 2 is equal to m, which is 2, times x minus 2, and so expanding is going to give us y equals 2x minus 4 add 2. So minus 4 add 2 is minus 2. A couple more things about straight lines. 2 parallel lines have the same gradient, and so m1 equals m2 for parallel lines. And for perpendicular lines, m1 times m2 is equal to minus 1. Or in other words, each gradient is the negative reciprocal of the other gradient. A circle with an equation of the form x minus a squared plus y minus b squared equals r squared has a center with coordinates ab and a radius r. So for example, a circle with center 5, 4 and radius 3 is going to have an equation x minus 5 squared plus y minus 4 squared equals 9. Let's say you're given the equation of a circle in an expanded form such as this. So what do we have to do to rearrange it into the form that tells you the center and radius of the circle? What we need to do is we have to complete the square on the variable x, and then we have to do it again for the variable y. So let's gather the x terms and the y terms. So we have x squared minus 2x plus y squared plus 4y minus 4 is equal to 0. So when we complete the square, we take half of the coefficient of x. So half of minus 2 is minus 1, and we put it in the bracketed form x minus 1 squared. We then take away minus 1 squared. And we do the same for y. We have a coefficient of 4. Half of that is plus 2. And we take away 2 squared. And then we take away our leftover 4. So neatening this up, we get x minus 1 squared minus 1 add y plus 2 squared minus 4 is equal to 0. And so transferring the constants to the right hand side, we get x minus 1 squared plus y plus 2 squared is equal to 9. And so from this form of the equation, we know that the centre of this circle is 1 minus 2. And we know the radius is the square root of the constant we have on the right hand side. And so the radius is 3. So let's finish off with a problem involving both circles and straight lines. So the point P 1 minus 2 lies on a circle with centre 4, 6. Find the equation of the circle. So let's sketch on the graph what we're told. We have a circle with a centre of 4, 6, and it goes through the point 1 minus 2. Since we're told the centre, then we already know half of the equation. We have x minus 4 squared plus y minus 6 squared is equal to the radius squared. And the radius is the distance between the centre and any point on the circumference. Unfortunately, we know one of the points on the circumference. So we need to find the distance between the centre and the point P. And the formula for the distance between 2 points is given by the square root of y2 minus y1 squared plus x2 minus x1 squared. So let's suppose that the coordinates of the centre are x2 and y2, and the coordinates on the circumference, or this point on the circumference, are x1, y1. So that will give us the square root of 6 minus 2 squared plus 4 minus 1 squared. And so that's the square root of 8 squared, so the square root of 64 plus 3 squared, so plus 9, is equal to the square root of 73. So r is root 73, and so r squared is 73. And so our equation becomes x minus 4 squared plus y minus 6 squared is equal to 73. Part B, find the equation of the tangent to the circle at P. From our circle theorems, we know that the tangent at a point is perpendicular to the line connecting that point to the centre. And so if we can find the gradient of this line here, then we can use the equation m1 m2 equals minus 1 to work out the equation of this perpendicular tangent. For the dotted line, the rise over run is, so from minus 2 to 6 is plus 8, and from 1 to 4 is plus 3. And so the gradient of the dotted line is 8 over 3. And so if we rearrange this a bit, then we have that the gradient of our tangent is minus 3 over 8. And now, since we know the gradient of our tangent and we know a point that it passes, of course it passes the point P, then we can use the formula we saw earlier in the video. Y minus y1 equals m times x minus x1. So y minus 2 is equal to minus 3 over 8, that's our value for m, times x minus x1. So if we multiply both sides by 8, then we get 8y plus 2 times 8 is 16 is equal to minus 3x plus 3. And so 8y plus 3x plus 13 is equal to 0.